In this lesson, we're going to discuss the Common Core Standard 8.EE.A.2. That's the 8th grade Expressions and Equations standard that focuses on the use of square root and cube root symbols to represent solutions to equations of the form x to the power of 2 equals p and x to the power of 3 equals p, where p is a positive rational number. Evaluate square roots of small perfect squares and cube roots of small perfect cubes, and know that the square root of 2 is irrational. In order to understand square roots and cube roots, it's first important to look back at information about a square versus a cube. On a square, we know that we have a length and a width, or a length and a height. But on a cube, we have a length, a width, and a height. So when we find the area of a square, we're always finding a squared unit. Base times height, length times width. Our answer is always square units. So we show that as units squared. In a cube, we're finding volume. Volume is three-dimensional versus two-dimensional. And we find that by multiplying the length times the width times the height, and that gives us units cubed. So knowing this part of the information does help us find the link between square roots and cube roots. First, let's look at the definition of the square root. The square root is a number that when it is multiplied times itself gives a specific number. So right now we're just thinking, okay, well, 2 times 2 equals 4, and so square root is just saying I should multiply times itself. Not exactly. Let's relate it to the actual symbols that we will usually see in a mathematical term. So here we have the radical symbol. It looks kind of like a division symbol with a little hook on the left side. And then we have the radicand, which is the A within the radical symbol. The radicand is a specific value. Together, the radical symbol and the radicand form a radical. So back to our square. What if I told you that if I put the square root of 25, so my radicand is 25 under the radical symbol, I put it inside the square. What if I told you that the square root of that 25 would tell me something about the side length of that square? Kind of stating that 25 is the area of the square, and the root is the side of the square. So some people like thinking of it that way. This is my root, and this is my area. So if the area of a square is 25, what is its side length? Therefore, the square root of 25 is 5. Let's look at another one. Let's say that we're looking for the square root of 36. Well, that would tell me my area within a square is 36. What is the side length? The side lengths are 6. So therefore, the square root of 36 is 6. If we go back to the definition of square root, it's a number times itself, which gives you a specific number. Let's do one more. So let's say we have 100. That's a pretty easy one to work with. So the square root of 100, our side length is 10. Our other side length is 10, so 10 times 10 is 100. Therefore, the square root of 100 is 10. Up till now, we've been dealing with what we call perfect squares. A perfect square is when a rational number times a rational number gives you your value. So, for example, we know that 2 times 2 is 4, and 3 times 3 is 9, and 4 times 4 is 16. So these all are perfect squares. They're going to give you a value exactly. But what if you run into something that asks you for an imperfect square? For example, let's say the area of your square is 83. So we're looking for the square root of 83. We're trying to figure out what that side length is. What is the side length if your area is 83? Well, when we look at areas around it, the closest one beneath it is 81. And that has a side length of 9 and 9. The next larger one is 100. And that one has a side length of 10 and 10. So when we go back to our square root of 83, we think about, well, over here, we've got the square root of 81. On the other side of things, we have the square root of 100, and somewhere in between is our value, the square root of 83. It has to be greater than 9, because 9 is the square root of 81. But it has to be less than 10, because the square root of 100 is 10. So it has to be greater than 9, but less than 10. Most likely, it's much closer to the 9 than it is the 10, because of the fact that when we look at reasonableness, 81 is 2 away from 83, while 100 is 17 away from 83. So if I were to take a guess, I would say that the square root of 83 is probably equal to approximately 9.2. When I put this into my calculator, I get the exact answer. And the actual answer is that 83 is equal to 9.1104335, and it just keeps going on, which is an irrational number. So I was close in my estimation, figuring it was 9.2. If I really wanted to see how close I was, I could have done 9.1 times 9.1 or 9.2 times 9.2 to check my work. But you can see how creating the tree does show us a little bit about the reasonableness of how to find our answer without a calculator. So let's look at the next thing, cube roots. So we looked at square roots, then there's cube roots. And how would cube roots relate to a cube? Well, if we go back to our shape, we'll remember that a cube is three-dimensional. It has length, it has width, and it has height. So if you remember, our answers are always in units. So our squares had units squared for the area. Our cubes have unit cubed for the area. So when we look at the relationship, we can pretty much figure out that in this case our A value is going to be the side length of a cube. So, for example, if I knew that my cube had a value of, get these out of the way. Okay, my cube has a value of 64 units cubed. So that would mean that the length times the width times the height had to equal 64. Those values had to be the same, so it's like saying side times side times side equals 64. So what is my side length? I can try different numbers. Knowing it's an even number, I should try to veer away from my odd numbers, but sometimes your odd number could be the answer. In this case, the answer is 4, because 4 times 4 equals 16, and 16 times 4 gives us 64. So therefore, the cube root of 64 equals 4. Let's look at another example. Let's say that our volume equals 125. units cubed. Now, what is the cube root of 125? Remember that we're looking for side times side times side to equal 125. Knowing that it ends in a 5, that kind of helps us out a little bit. 15 times 15 would be too big, and we'd still have one more 15. So let's try 5. 5 times 5 equals 25 times 5 equals 125. So the cube root of 125 is 5. Notice I don't have anything next to the 5. The answer is 5 by itself. It is the side length. You don't put a 3 next to it with an exponent. You don't put a 2 exponent. You just have the number 5. That is the value of your cube root. Let's try one more example. Let's say the volume of your cube is 27. So blank times blank times blank has to equal 27. Your side times your side times your side has to equal 27. 2 times 2 times 2 is 8, so that's not it. 3 times 3 times 3 does equal 27, so the cube root of 27 is 3. This concludes this lesson, which will lead into Pythagorean theorem, which utilizes square roots on a regular basis.